Okay, pre-calculus students, we have one problem here left to finish up, and it's not really a problem, it's the exploration from the beginning of the chapter. And we have Jim and Barbara, they're house hunting. They need to estimate the size of an irregular adjacent lot that's described by the owner as a little more than an acre. With Barbara stationed at a corner of the plot, Jim starts at another corner and walks a straight line toward her, counting his paces. They then shift corners and Jim paces again until they've recorded the dimensions of the lot in paces, as in figure 5.29. So there's our little figure down there. Oh, what else do we have here? So they later measured Jim's pace as 2.2 feet. What is an approximate acreage of the lot? So this is going to have a lot of, hey, let's convert this information as we go through it. And it's got steps 1 through 6 to help us out here. And I started to record this earlier, but the audio wasn't working. So hopefully now it is. I'm not going to erase what I have here. I'm going to take you back through it. So we've got two triangles, and it said use herons, which makes absolute sense because we have side, side, side situation here. And I went ahead and made this top right triangle, triangle sub 1, and the bottom one sub 2. And to find the area of area sub 1, I had to figure out what the semi-perimeter is for that triangle. So that means that we had to add 112 plus 102 plus 86 and divide it by 2. And that gives you 150. So this is the formula for herons, and there's S, the semi-perimeter. And then you take each of the side lengths and subtract them from 150. So 150 minus 102 gets you the 48. 150 minus 86 gives you the 64. And then minus the 112 gets you 38. And then we pop that into the calculator. So we had 150 times 48 times 64 times 38 second square root of that answer. And I'm probably going to need this later, so I better store it. Store alpha A. 4,184.543, but this is in square paces. That's really important because, like I said, most of this is about conversions here. And then I go to the second triangle. And the second triangle, we have to figure out what the semi-perimeter is. So 81 plus 112 plus 115. Oops, not 155. There, divided by 2. So the semi-perimeter in that one was 154. I'm going to go ahead and put my little calculator key for that one on there so I don't forget about that. And then we have 154 for the semi-perimeter, and you have to take 154 minus 81, 112, and 115, and so you didn't have to watch me punch all that subtraction in. Those numbers are right there. So now I have to work on getting that answer for the area of the second triangle. So 154 times 42 times 39 times 73. And all of this, again, we're able to do because it's a side, side, side situation. 4291.0200 to 3 decimal places. So let me put that in storage as B. All right, so A and B are sitting in there waiting for what I have to do next. Now, this again is in square paces. And since what I really want to do is figure out the area of the whole thing, that would mean I need to add my A and my B together. So alpha A plus alpha B. So there's the area of, well, it's not a parallelogram, it's just a quadrilateral. You know, that's what we're looking at there for that space. So we have 8,475.743 square paces. And yes, gonna need that. So let me store that as C. And again, write that down so we don't forget where it is. So there's number one. Use Heron's formula to find the area in square paces. Number two says, let's convert that area to square feet using the measure of Jim's pace. So right now we have 8,475.743 square paces. We don't want square paces when we're done. So we're going to use unit analysis and get something that we know about square paces, not just paces. And what we do know, if we go back up, we read that they measured it, and Jim's pace is 2.2 feet. But I need square paces. So what I'm going to have to do is I'm going to have to square this so I can use it for my conversion. Now this is just work I'm kind of doing off to the side here. So we need 2.2 squared, and that's 4.84 square feet. And 1 times 1 is 1. So now we've got square paces times square paces in the denominator, which will cancel out. And doing the multiplication here will get us our answer in square feet. I see I already have an equals up there, but I'm going to go ahead and move it down here so that it's kind of central to what we have. So I have that stored in C, and I need that times 4.84. And I need to store that information because we are not done. So store alpha D. Whoops, alpha. Store alpha D. So I'm having the same problem as yesterday where I am touching things and it is not recognizing it. So I'll have to make sure I hit it a little bit harder as I go through these problems. So here's our D. And that was 41,022.595. Square feet. Whew. All right. So that was the answer to number 2. Convert the area to square feet using the measure of Jim's pace. Number 3. Number 3 says, let's keep working. We're trying to go to acres here. There are 5,200 feet in a mile. Convert the area to square miles. That's what we're starting with. We need something with square feet, with miles, so that we can figure out what we have in our conversion. So square feet, square miles. We know off to the side here that 1 mile is 5,280 feet. But we're going to have to square that. 1 squared is just 1, but we need 5,280 squared. There it is. Get this to where I can see that and still write this down. All right. So we're going to be able to cancel out square feet. Top times top will still leave us with 41,022.595 times 1. Not going to change it. But now we'll have to divide that by that nasty number that we just had. So last storage was in D. So alpha D. There we go. And I need to divide that by the last answer that I just had up there. So there it is. And that is going to be in square miles. Now, because this is a decimal that if we round to 3 decimal places, we're going to be stuck with a little 0.001. And we want to be much more accurate than that. This is something, unfortunately, I'm going to encourage you to write the whole thing down. And I'm going to store that in E. So there's our square miles. Step 4. There are 640 square acres in a square mile. And usually we don't say square acres, it's just acres because acres are considered to be square units. But this is what we have right now. And they just told us 640 square acres in 1 mile. So with this one, because acres are already considered to be a square unit, we don't square both of these. Acres are, that's exactly what they are. For farming, for any type of land, they are square units so that you can tell people how many acres you have. So this one doesn't require any conversions. Because acres are already in square units. But we do have to take that answer from before, which was E, and multiply that by our 640. And there is the acreage. So then we get to number 5. And it says, is there good reason to doubt the owner's estimate of the acreage of the lot? Well, yes. I mean, you're talking about 0.94 versus what they said for the acreage was a little more than an acre. So if the paces are actually 2.2 feet, you'd start to wonder, is this person trying to sell me swampland in Florida? So is there good reason to doubt the owner's estimate? Yes. What we see here is you better get a more reliable estimate. So yes, get a more reliable estimate. Don't go off of Jim's paces. Go back out there with some tools. Hire somebody that's working with all of the things that you need when you're trying to measure land. And we've talked about that before. That surveyors are using tools that are the correct tools for these jobs. And then number 6 says, would Jim and Barbara be able to modify their system to estimate the area of an irregular lot with 5 straight sides? So if they had 5 sides, could they use the same method of measurement with paces? And the answer is absolutely, because what they would do is they would just increase the number of triangles. In fact, you did this back in geometry before you knew a formula to figure out the area of any polygon. So yes, you could always divide a polygon into triangles. But like we said, if you're going to talk about land and you want to make sure that you are getting the land that is being advertised, it's not somebody that you can normally trust. What you have to do is think, hey, can I actually figure out what this land is. And if you're under, absolutely, get somebody out with the correct tools, get some surveying equipment, and make sure that they've got the transits out there, because that's the tool that's used for that. And figure out, hey, are they trying to short us here? Is this actually less than an acre when they say that it's more than an acre? So like I said, this really did not affect your assignment. There wasn't really anything about acreage in the 5-6 day 2 assignment, but it's an excellent problem to remind us that unit analysis doesn't go away, that a lot of what we're doing is try to make us educated consumers. So that is it. And as we talked about in class, it would be a really good idea for you to go ahead and take another look at the 5-4 videos to make sure that you're ready for the test on Tuesday.